rewriting this radical in rational exponent form. Remember, rational exponent means fractional exponents. So we have base x, and it's raised to a fractional exponent. What goes on bottom? Roots, right? So 5 goes on bottom, and then power goes on top. 2. So how many of you got it right? Awesome. Now remember, these two things are equal. They're just two different forms. This is apples, this is applesauce, but they're the same thing, just in different forms. Now the reason we learn both ways is sometimes radical form is better, more useful to us, and sometimes rational exponent form is more useful to us. All right, so a couple things. We're going to review how to do some of it so that hopefully we can remember how to do it. Yeah, Tyler. So you're going to have to kind of be patient. Okay, look at this one, guys. Let's rewrite this in radical form. Is 25 and x raised to the 2/3 power? You can all just look up here. This is review. Yeah, they're both raised to the 2/3 power. Roots go on bottom. So we're rewriting it as a radical. What root is it? It's a cube root. Let's all practice saying it correctly. 1, 2, 3. Cube root. It's the cube root of both 25 and x. Aren't they both raised to the second power? So I need my parentheses, right? Otherwise, we would not have 25 being raised to the second power. So we're done. This one was a little bit trickier. Is there any parentheses on this one? No. So is there anything specifying we do anything with 25? No, right? 25 is not raised to the 2/3 power. Just this piece is. So isn't this just 25 times by x to the 2/3 power? Okay, so isn't this just 25 times by the what root? Cube root of x to the second power. And we're done. Is everybody good with those two? Questions on that? Okay. Okay, let's rewrite these radicals in rational exponent form. I'm going to ask you a question. Is 5 and x both raised to the 3rd power?
Yes, ma'am.
Is 5 and x both under the root?
Yes.
Yes, so this one's the easy one. They're both raised to the roots are on bottom, so 2 goes on bottom, right? Square root of 5x cubed. So power's on top. Is everybody comfortable with that one? Okay. This one was probably the hardest one of them all. Okay? Are they both, is 5 and x both raised to the 3rd power? No, only x is raised to the 3rd power. But are they under the same root?
Yes.
Yes, so we got to go about this one a little bit carefully. Hopefully the second time you see it, it will make more sense. So we leave them with their individual powers, right?
Yes.
Right? But since they're both under the same root, there is going to be parentheses. Now look, if I put parentheses out here, does that make my 3 go to my 5 too?
No.
No, so are my parentheses hurting me at all here? No, okay. So they're both under the same root. Roots go on bottom, so 2 goes on bottom. Well then what the heck goes on top?
1.
1, right? There's a 1 up there. So we can always write a 1, right? 1 times anything's just itself, right? Are we all okay with that? So this would be our answer for this one. Okay, questions? Anybody? Okay, so that was just a good review. Okay, now also first hour just struggled tremendously, so I added in this slide because we should know this by now. So let's go through this, guys. This is just some basic math here. X plus x.
2x.
2x. I'm so glad you didn't say 2x squared. We all understand it's just an apple plus an apple is 2 apples, right? I think we're past that point. I thought.
I hope.
Well then, do you see the difference between plus and multiplication?
Yeah.
Okay, so what's x times x?
X squared.
X squared. And you got that because there's a 1 and a 1, and then we add them, right?
Yep.
Okay. What's x squared plus x squared?
2x squared.
2x squared. Very good. We're all okay with this? Very good. Well, what's x squared times x squared?
X to the 4th.
X to the 4th. Awesome. Now look how different those answers are. Very different. Addition, combining like terms, versus multiplication, properties of exponents. 3x squared plus 4x squared.
Well, that's 7x squared.
3 plus 4 is 7, and we're dealing with x squared. Very good. Are we okay so far? Okay, what about x squared plus x cubed? Can we do it?
To the 5th. Oh, no, never mind.
What is it? Yep, you're right. So we can't combine them. So it's just x squared plus x cubed. Very good. Guys, we all understand we can't combine those, right? Huge no-no. Okay, what about this one? 2x Could we do that one?
Yes.
Yes. When you multiply, you add your exponents. So 2x to the what? 2 plus 3 is 5. Okay, so we're all okay with that, right?
What's the song?
And we're going to sing it in a minute. Okay, so remember, this is what we learned. We're applying just everything, a lot of things that we've learned together today. So remember that on Friday we learned this little picture of our flower that helps us rewrite rational exponents. Roots go on bottom of a flower, right? And so does the root of a rational exponent, fractional exponent. Power comes from the sun, coming from the top, power is on top. So let me read this, everybody, so that you can read it correctly. This is the, not blank root, not one root, there's no such thing. This is the square root of x to the third power. Because powers go on top, we put the 3 on top, roots are on bottom, so it was a square root, so 2's on bottom. We're all okay with that, right? Just making sure. Okay, so now we're going to apply that knowledge and our knowledge with properties of exponents all together. So let's sing our song. Now, first of all, before we sing the song, remember that the song only works if we have the same base. So I'm going to ask you guys a quick question. Is x and a y the same base? No? Okay, what about A and B? Those aren't the same base. What about 2 and 3?
Yes.
Are those the same base? Nope. What about 3 and 3? Are those the same base? Yep. What about A and A? Same base?
Yep.
Okay, good. Okay, now if you have the same base, then our song holds true. Let's sing it. When you multiply, you. When you divide, then you. Raise a power to a power, and you. Okay, good. So let's use our properties of exponents. Same base? And we're multiplying, so we add our exponents. So this will be x to the fifth. The song does not go, when you multiply, you multiply. Don't multiply them. Okay. When you divide, then you. The top from the bottom always, right? If it's a negative exponent, isn't that true? Still? What about fractions? Still? Yeah. So we're doing x to the 3 minus 2, which is x to the 1, which is good. Well, let's see. We have x to the third power raised to the second power. Raise a power to a power and d. Okay, 3 times 2 is good. We're all okay with that. Okay, so then from here, I'm just going to do some advanced examples here. So we're combining two things. We're simplifying first using properties of exponents when we can, and then we'll rewrite it in radical form. So I'm going to urge you to pay attention to the little details today. Okay? Watch very carefully, because I'm doing examples exactly like what you're going to see. Alright, so let's look at my first example here. X to the 2/3 times x to the 5/2. We have the same base. And we're multiplying, so we add our exponents. So we're doing x to the 2/3 plus 5/2. Now you'll type it into your calculator, because you can't just add straight across. Fractions have to have a common denominator. So let your calculator take care of business. Everybody practice typing it in. 2 divided by 3 plus parentheses 5 divided by 2. You should all practice typing it in. X to the what? Good, 19/6. That's our answer. But, so we've done the first part. We've simplified, but now we need to write it in radical form. So what root is this? What root?
6.
A 6th root of x to the what power? 19. So this is the final answer. We took this applesauce, or apple, and we turned it into applesauce. Remember, they're just different forms, but they're equal. Are we all okay with that? Okay, awesome. Next example. Now this is where people, and even though I've done this example, people still say, they'll pull me over and say, I don't know what to do. So you guys pay attention. We have x to the 1/2 times xy to the 2/3. Okay, let's think about this, guys. Isn't this all multiplication? Yes. Okay, isn't all this stuff being raised to the 2/3 power? Yes, and isn't this a power 1 and a power 1? All right, so we're going to take 2/3 and distribute it through. We're raising a power to a power, so we multiply. So right here we have x to the 1 times 2/3. 2/3. 1 times 2/3. Y to the 2/3. So does everybody see how I just rewrote this? Yeah? All right, and then we have x to the 1/2 still.
That's almost right.
And it's all being multiplied, right? Bing, bing. Okay, so let's go through and simplify. when you multiply the same base, you add your exponents. So we have x to the 1/2 plus 2/3. And then don't we have this y to the 2/3 that doesn't have anything to simplify with it?
Yes.
Okay, so let's do it. Let's make that 1x. Somebody should have it by now. 7/6. So we have x to the 7/6, y to the 2/3. Can we combine x and y here? No. So we're almost done. We've simplified. Okay, does everybody understand we've simplified?
Yes.
That's our first step. So now we'll rewrite it in radical form. Well, let's just do it. Isn't this just x to the 7/6 times by y to the 2/3?
Yes.
Okay, so let's rewrite each piece in radical form. That's the 6th root of x to the what power? Times by the cube root of y to the 2nd power. And there's our final answer. Questions on that? You're sure? You're all okay. So the first step was to simplify. We did that using properties of exponents. Once you've simplified it and have only one base of each type, then you'll rewrite it in radical form. Okay, couple more, and then I'm going to let you work. You're not going to have homework, so it's worth it for you to stay with me, okay? So look at this. We have all this stuff being multiplied, right? So these parentheses, well, first of all, is there any addition signs in here? No, so we can just drop off the parentheses. This is just simply 3x squared times 2x to the 1/2. Then from there, can't we just reorder it in any order? 3 is not connected to x squared, guys. So we can reorder it. So I'm going to do 3 times 2, 3 times 2, and then I have an x squared times x to the 1/2. Does everybody understand? I just put it in the order that's going to make it easier for me to simplify. Okay, let's simplify it. 3 times 2 is 6, and then right here we have x to the 2 plus 1/2, right? 5 halves. So then from there, is 6 raised to the 5 halves power? No. So we know this is 6 times by the square root. We don't write the 2 in, do we? Because square roots don't have a 2. And then x to the 5th power. So the first thing we did was simplify, and we got here. Then we rewrote it with in radical form. Is everybody okay and comfortable? You're not feeling freaked out? Okay. Okay. Now this one's probably the hardest one, just because a lot of students kind of get confused. They confuse this one with one other one we've seen. So I'm going to ask you, is there any potential to simplify here? We have an x and a y to the 2/3 power, right? And then we have 2. So there's no, this is the most simplified form, right, everybody?
Yeah.
So I don't need to distribute the 2/3 through, because this is the simplified form. The reason we did it over here was because we needed to do it so that we could combine our x's. But with this one, there's going to be no combining. So it's done simplified. Let's just rewrite it in radical form. Is 2 raised to the 2/3 power? No, so it's 2 times by the what root? Cube root of x and y, and it's both
Square root. I mean, to the
square. Very good. That's in radical form. So there was no simplifying, right? We can't combine x and y. 2, same thing. So this is in radical form. Questions on that? Okay. All right, so now I'm going to have you practice problems 28 through 30. We're going to be jumping around, so it's the back side of 5-1. The back side of 5-1, that's where we're at. Okay, so looking at this, we're going to rewrite each expression using one base only. So now let's look. What are we doing here? Well, can we use properties of exponents? Do we have the same base?
Yeah.
2 to the 2? Is those the same base? Yep. And we're multiplying the same base. So what do we do with our exponents? Add. So 2 plus 3 plus 4. 2 plus 3 is 5. 5 plus 4 is, so this is 2 to the 9th power. And I don't need you to actually multiply that out. Obviously, you could type in 2 raised to the 9th power. But if you read the instructions, it says, rewrite each expression using one base only. Isn't this using one base only? Okay, so we're good with that. Now understand something, guys. This is one of the most common errors is if somebody, like, let's say on a test I said 3 to the second times 6 to the second. Are those the same base? No, so you can't just do 3 times 6 is 18 raised to the 4th. Does that make sense? You can't do it. So this is as simplified as it goes. Does that make sense, everybody? Okay, so you see the difference there. All right. But you could calculate them individually, right? And then just multiply them together. And that's what we'd probably do. Okay. So let's do this one. We have the same base in all cases. And we're multiplying the same base. So we add our exponents. 5 plus 4 is? 9. 9 minus 6? 3 minus 2? So 3 to the first, which is just 3. But this is a good answer. It just says rewrite it with one base only. Questions on how to do those ones? Pretty easy, right? So what if I changed it up and said 2 to the 5th over 2 to the 3rd? What is that? 2 to the what?
Second.
Good. 5 minus 3 is 2. 2 to the second. Okay, so just saying. All right, guys, do problems 38 through 41. Here. Okay. Now for these ones, guys, pay close attention. I'm just going to go through some examples. This is just properties of exponents, which is stuff we've learned at the beginning of the year. Right? So it's really nothing new. But let's just go through some examples. We have 25 raised to the 1/2 power. Well, we could rewrite it as a radical if we wanted, right? This is the what root? Square root of 25 to the what power?
Nothing. Just 1.
First, there is something. It's a 1. So that's the square root of 25. Type it into your calculator. What's the square root of 25? 5. Okay, so we got answer is equal to 5. Now I'm going to teach you something. Pull out your calculators. Type it in like this. Don't do extra work. We could rewrite it in radical form, but why not just go like this? Everybody watch. 25 raised to the parentheses 1 divided by 2. It was 1/2, right? And I get 5. Which is what we got, right? Makes sense? It's just different ways of typing it in. So it's equal to 5.
But I can't do with that one, huh?
What?
Is there like some fancy trick to do with the next one right there?
Well, they're equal, right? Because this is just apple salt and applesauce, so they should be equal, their answers. What?
What about this one?
Okay, look at this one. We have a bunch of parentheses. Do you see any addition signs? No? So we're just multiplying? So can't we just drop off the parentheses? So we have x times x to the negative 3 times x to the negative 4. What? Do not make the comment or saying, oh, no exponent. There is. What's the exponent? 1. When you multiply the same base, you add your exponents. Negative 4 plus negative 3. Negative 7 plus 1. X to the negative 6. Is this answer acceptable? No, we don't accept negative exponents in our final, most simplified answer. So we know we draw our line, grab our base to the negative exponent, flip it over a fraction. That'll fix it. It's now x to the positive 6, right? Don't flip it and write a negative again. Okay? Well, what's left on top? 1 over x to the 6. That's how I expect you to write your answer. Everybody good with that one? Okay, now let's look at this one. Stay with me, guys. It'll be worth it to you. You're not going to have homework yet. You're going at a good pace, so stay with me. Look at this, guys. Do you see any addition signs in here? Nope. So we're just multiplying all this stuff. So can't we just drop off the parentheses? 2x cubed times negative 2x to the negative 5. And then is 2 connected to x cubed? No. No. Is negative 2 connected to x to the negative 5? No. So let's just reorder it. 2 times negative 2 times x to the 3rd times x to the negative 5. That helps us simplify. What's 2 times negative 2? Negative 4. What's x to the 3rd times x to the negative 5? Good. We add, right? So negative 2. Then we flip anything with a negative exponent over a fraction. Is 4, this is the most common error, is 4 a negative exponent? No, it's a negative number. It needs to stay put. The only thing we fix is with our base with our negative exponent. We flip it to the bottom. It's now positive. I will not accept that answer. It's hideous. We go off to the side and rewrite it. Negative 4 over x to the positive 2. Okay, good. We're getting good at properties of exponents. Last one, and then I'll let you work. Look at this. It looks scary and it's really not. We will see stuff on this advanced level here. It looks scary, guys. It's not scary at all. Do we have any addition signs? No, we're just multiplying. So let's reorder it. -2 times 3 times 3. And I'm going to cross them out so I don't miss anything. We have an x squared, and an x to the 4th. Cross them out as I go so I don't miss anything. A y cubed, a y to the -7. Does everybody see how I just reordered it? And now in sections we'll simplify. -2 times 3 times 3. -18. Right here, when you multiply at the same base, you add your exponent. My exponent on x is a 1. 4 plus 2? 4, 5, 6 plus 1 is 7. X to the...
7.
And then right here, do not say there's not an exponent on y. There is. It's a 1. -7 plus 3 plus 1.
-3.
Y to the -3. From there, we flip anything with a negative exponent. Draw your line, grab your base, flip it over a fraction. So it's y to the +3. Now, once again, that answer is not pretty, so go off to the side. -18, x to the 7's on top, and then a y to the +3's on bottom. This would be how we write our answer. Is everybody okay with this? Really, you should feel good about today. It's just more advanced problems of stuff we've already learned. Okay, good. Okay, so do problems 42 through 51. Ready, set, go.
Does mean these first 6 we'll just type into our calculator?
Yeah. So the first 6, you'll just type into your calculator. You're right. Don't do extra work. Just type it in. So the first few you should just be typing into your calculator. 16 raised to the 1/4 power. Don't make it harder than it needs to be. Oh, one more thing though. Just saying. Okay, this is a good thing to know. Let's say we did 2. No, let's go like this. Actually, I'll bring you back to me in just a second. Keep working. Yeah.
Yeah, 46.
4 plus 2 is? 6 plus 1 is? 3 plus -4, right? Is that what we're doing? Yeah, there you go. The other one was 6. Yep. Yep, no, you're right. It's not a negative exponent. You're right, but it needs to stay on top. Check with me as you go or as you're done. Now we're just pulled up.
Smart. I'm smart.
Yeah, but I want to finish my packet today. After school, give a few checks over the 9. Take the test tomorrow after school. Get another packet, do a little break. You guys can test.
Okay.
And another. So I can hang out with Snell, which is equal to Rosie.
Stuff is changing.
Oh, good, yeah. all right.
Then you overachieved.
It was home.
You got 49.
Almost ready to move on.
Oh, Lord. I know what I'm doing.
You gotta put this in. Yeah, so it's 25 raised to the 3 divided by 2, like that. Oops. Are you so flippant?
Maybe.
Math and furniture. I don't want that little guy.
I broke them.
Caesar's away though.
Get checked before you get wrecked, so.
I can order a
Hey,
Dad, go get a drink.
Hey, what?
4 plus 2 is plus 1 equals 0.
No. No. I have first.
I asked first. I asked first.
You smashed my
I asked
paper.
first, Willis.
So G, so negative 3 plus 1 plus negative
Why do you
2,
think
right?
your iPod's so strong? Sister lends a 10.
Now take the elevator, too.
I call you Miss Chris.
Yeah.
Dustin.
I call you Miss Chris.
Can I call you Miss?
Statue? Is there any addition signs in there?
Wait, is that your full, is
Okay.
that your first name? Like your full first name?
What?
Good, Whitney. It's not like abbreviated.
What would it be abbreviated for?
Is your mom's first name Penny?
Yes.
Is that not abbreviated? You have to do an abbreviated name.
When you multiply it,
Good dog. Good dog.
all right, moving on.
Hold on, one more minute. Maybe 47.
Negative 42. So it should be negative 1 plus 1 plus 1 for y. Yes, you're also down there. It's not right. Look, negative 2 base was negative x 1 over fraction. With that one, right? With that, but please don't go down to that either. And the negative part is going on.
Okay. She's
Good. Don't forget about the 1. So there's an x to the 1. How you say that? 2 plus 1 is 3. 3 plus, yes. Okay.
your mom got
One. Get a y to the 1. Yeah, we have 2 y. 1 and 1 and 1. Fix that one. Do we add, do we multiply and do we add? No, right? Over 3 is
Did I ask for an opinion for a video?
one of them is the right, right? So the right square is the right. Oh, and then x is the negative. X the negative 1
There's too many people.
Because my mom just is more. We're gonna go to
We multiply.
And then down
No, right? We got 3 plus 1 plus negative 2. 3 plus 1 is 4. 4 minus 2. Moving on, guys. I do. That's why I'm so in shape. All right.
Wait, you're in shape?
Well, yeah.
When did that happen?
Oh, shoot. I hope I didn't leave that recording the whole time. All right, guys. So we have 2x. So scientific notation of numbers. Everybody pay close attention because I'm afraid you've never seen the scientific written number, which you should have. Guys, if you're in science and you've been in science for the past 20 years of your life, you've seen a scientific number. So guys, scientific numbers, this is times 10. This is not an x. So this is 2 times 10 to the negative 2, and we're multiplying it to 3 times 10 to the 6. Now times 10, that is not an x. That's like a multiplication sign. That's the only time that you ever write a multiplication sign as an x, you know, back to grade school. That's just how scientific numbers are written. Okay, so with this, we're just going to multiply these 2 scientific numbers. This is just a multiplication sign, everybody. Does everybody understand that?
Yes.
Okay, so we're just multiplying all these things together. So let's multiply the white parts. 2 times 3. 6. And then we have 10. We're just multiplying all this stuff. We have 10 to the negative 2, 10 to the 6. Aren't 10 and 10 the same base?
Yes.
So when you multiply the same base, you add your exponents. So 10 to the
10 to the 4th.
4th. And then we write it scientific numbers, so it's 6 times 10 to the 4th. This is our answer.
That's easy as heck.
Now guys, everybody, let me show you how to check your answers. Are you ready to type it in? So type it in exactly like this. Type in parentheses, 2 times by, it's literally multiplied by 10 raised to the negative 2. Close your parentheses. Times by 3 times 10 raised to the 6. You get, if you do this in your calculator, you get 60,000. So everybody tell me if you got that. Okay. Type this into your calculator. 6 times 10 raised to the 4th. You get 60,000. Guys, understand? This is equal to this. This is equal to this. This is just written as a scientific number. They took the decimal and moved it 1, 2, 3, 4. Whoa, did I skip something? 4 places. Does that make sense?
Yes.
That's why it's times 10 to the 4th. You should know how to do scientific numbers. It's really easy, right?
Oh, now I do.
So do 52 through 55. Ready, set, go. All right, last thing here. So now we're going to be asked to find the area of different objects. So now we're going to be asked to find the area, guys. We're asked to find the area of different objects. So we're going to have to know some area formulas. So area of a square or rectangle is length times the width. These are just things you have to have memorized. On the end of level test, on the ACT, on my upcoming test, you just have to know these formulas. Okay, area of a circle is pi times the radius squared, pi r squared. That's how you find the area of a circle. And then the area of a triangle, now this only works, you can only find the area of a triangle if you're given the height using this formula. So if we have a height drop down perpendicular, meaning making a 90-degree angle, then we can use the formula 1/2 times the base times the height. This is our base, this is our height. Now in secondary math 3, you actually learn how to find the area if you do not have a height drop down, because you can't use this formula otherwise. So in secondary math 3, you learn how to find the area of any triangle. But in here, this is probably this is as advanced as we're going to get. Okay, 1/2 times the base times the height. Are we all okay with that? Okay, so guys, look at these with me. You don't need to take notes. Just watch me very carefully. Pay attention to the little details. So it says find the area. Look at this first rectangle here. Can we actually find the area? No, we have some variables. Can't we set up a statement though? Yeah. So we know area is equal to the length times by the width. Now everybody pay close attention. I don't want to see any of you make this error. Isn't the length all of that stuff? So isn't it all that stuff times all that stuff? So don't we need to put it in parentheses? Yeah. So we have 3 plus 4x, our length, times by our width, which is 2x. So 2x is just one term, so I don't need to put that in parentheses. Does that make sense? Isn't that all the length times all the width? Okay. Now we're not done. I'm going to push you to go further. We can distribute 2x through, right?
Yeah.
Right here, pay close attention. For some reason, somebody had some issues with this last hour. 2x times 3.
Is
6x.
6x. Is everybody comfortable with that? 2x times 4x.
is 8x
8x
squared
squared.
And wasn't it plus?
plus 8x
Right?
squared.
Plus 8x squared. Then can you combine 6x and 8x
No,
squared?
you can't.
No, you can't. So that's our area statement. Is everybody comfortable with that?
You forgot the A.
Area is equal to. Questions on that? Okay, what about this one? Area is equal to, we would just have to look at this and say it's a circle. I know the area is 5 times the radius squared. So area is equal to pi, which is just a number.
3.11.
Approximately 3.14, we'll write it as pi. What's our radius? 2x, don't I need to put it in parentheses?
Yeah.
The whole radius
Is being squared.
squared. So then wouldn't that be pi times, isn't this 2 squared x squared? Wouldn't you square both of those?
Yes.
Yeah.
So we have area is equal to 4, right? 4 pi x squared. 4 pi x squared. Right, everybody?
Yeah.
Now the reason I put the 4 first is because that's just how they write it. So they would never write pi 4x squared. They just don't. They write it 4 pi x squared. Does that make sense?
Question.
Yeah.
Remember, you were told that pi equals 3.14, so you figure that out.
No, you still couldn't. Pi is always 3.14, right?
So can you-
Approximately. But you couldn't figure it out because we don't know x. But what if I said this? And x is equal to 2. Then couldn't we find the actual area?
Yeah, but what I'm wondering is
Oh.
like, or as pi length before that's 3.1 down.
Oh, yeah. Yeah, but this is, 3.14 is an approximate, you're rounding, right?
Yeah.
Pi is being exact, so we'd leave it as pi.
Okay, so a balance of pi is going to be this.
3.14.
If you figure that
Yeah,
out.
yeah. But this is actually like the prettiest form because it's most simplified. Because that's like the full decimal. You know what I mean? All right, let's do this last one. This is probably the hardest one. So area is equal to, we have a triangle, we have an altitude, a height being dropped down. Area is equal to 1/2 times the base times the height. Let's plug it in. 1/2 times our base. What's our base?
It is x squared plus 5x.
And isn't it have to be in parentheses?
Yes.
Yep, times the height, which is 7, right? So then we need to distribute it through. So 7 times x squared.
7x squared
7x squared. 7 times 5x.
is
Positive 35x. Now don't forget 1/2. Hey Brian, guys, I'm not finished. Okay? We still have the 1/2, right? Isn't the 1/2 multiplied to all that stuff?
Yes.
Okay. So now this is how they would rewrite it. Couldn't you distribute 1/2 through?
Yes.
But wouldn't that mean that it would be 7x squared divided by 2 plus 35x divided by 2?
yes.
Right? So this is actually probably how they'd write it. 7x squared plus 35x all over 2. Because that's the same thing as multiplying by 1/2. Right? Multiplying by 1/2 is the same thing as taking that whole thing and dividing by 2. Are we all okay with that? So this is how I want you to write it. Just because I think that's how you see it. Okay, awesome. So now do problems 56 and 57. Those are the last 2 required of you on the worksheet. It's due at the end of the hour.
Oh my gosh, do I have an extra day since I was gone?
So if you were gone, you'll have to